Example 5, 6, and 7, we are solving the equations. And so on example 5, this is already in factored form. This is exactly what we did in example 4, but now all we're doing is finding the zeros. We don't care about the multiplicity. Does it touch? Does it cross? I'm just looking for what does x equal, which is what your zeros are. So this one already being in factored form, we're just going to take all of these and set them equal to 0 and solve. So my first one is 3x plus 1 equals 0. So notice this is not going to just equal x equals -1 because of this 3 out in front. So the first thing I'm going to do is subtract that 1 over. And then I'm going to divide by this 3 right here. And so we get x equals -1/3. Do the same thing for this one here. And because this one is just x plus 5 equals 0, no coefficient in front of that x, you subtract that 5 over. And we get that x equals -5. And then our last one here, if I have 2x minus 1 equals 0, add your 1 over, and then divide by 2, and we get x equals 1/2. Okay, so we get those fractions here when I have a number in front of that x. So don't just assume that this is x equals -1 and x equals +1. Work through the problem. Okay, now I have this note here that solving polynomial equations, which includes quadratics, is the same as finding the zeros / x-intercepts of your graph. So if I put this in my graph here, and you put it in exactly the way it looks, I'm going to go on a standard graph. I know what my zero should be, so it will easily fit on a standard. So zoom 6. Here is my polynomial. So we can see it's a cubic. It starts down and ends up, which does make sense because positive times positive times positive means it's a positive coefficient. And all of these have a multiplicity of 1, so it's crossing, it's crossing, it's crossing. Now, if I want to check these, I'm going to hit trace and then -1 divided by 3, enter, and I can verify that that is a 0 because y equals 0. Then if I want to check -5, y equals 0, so yes. And 1 divided by 2, we get y is 0. There it is there. So all you really need to do when this is in factor form, solve for your x's. You can put it in your graph and you can solve it. Now, for example 6 and 7, these are not in factored form, so these aren't as easy as number 5. So I'm going to show you how to solve these by hand, but if you don't like solving them by hand, I'm going to show you how to just go straight into your calculator. So, to solve this by hand, first we look for a GCF. My GCF is x squared. You have x to the 4th, x cubed, x squared. You can divide 2 x's out of all of those terms. So I'm going to pull out an x squared, and that leaves me with x squared plus 8x minus 20. Okay, all we're doing when we're pulling out that GCF is undistributing. So if you distribute that x squared back into everything, we're back up to that original. So now I need to factor what's on the inside. So we have our a times c, which is 1 times -20. And my b term is 8. What adds up to 8 but multiplies to ac? Pause the video if you want some time to think about that. Okay, that's 10 and -2. So 10 times -2 gives me -20, but 10 plus a -2 is a +8. So because this is an easy trinomial, this is what it factors to become. So we have x squared, then x plus 10, and x minus 2. Now this is in factored form. Now I'm starting where this one started. So we have x squared equals 0. To get x by itself, we'll take the square root of both sides, and the square root of 0 is 0. We get x equals 0. Then I have x plus 10 equals 0. Subtract that 10 over, and we get x equals negative 10. And then last one, x minus 2 equals 0. So x equals 2. Now again, not hard to do, but we haven't spent a lot of time on factoring. So if you want to just go straight into the graph and find those x-intercepts, that's going to get you the answer as well. So if I come in here to my graph and I type in my original equation, I can see that this will still fit on a standard. This might be a little bit tight, so I will go into my window and change my x min to maybe negative 15, just so that that will fit. And specifically when these are whole numbers, we can easily see all these answers, right? I can count, that's 1, 2, 3, all the way to negative 10, and then we'll just check it. Trace negative 10, yes, my y is a 0. I can see that that's just touching right there at 0. And when I type in 0, we get a y of 0. And why is that just touching? Because we have an x squared. That multiplicity is 2. And so it's just going to touch that x-axis, but not cross through it. And we can count 1, 2. That's 2 right there. Okay, so let's just try using the graph straight from this one right here. And then I'll show you how to do this by hand if you're interested. So let's type this in. I'm going to go zoom 6 to see if it will fit right here on a standard. And it does. Okay, we know we have x cubed. So it's going to have at most 3 zeros, and it does. 1, 2, 3. And it's a positive leading coefficient, so it's going to end going up. So here, the furthest one is 1, 2, 3, 4, 5. So let's do trace 5 to verify that. Oops, that's negative 5, isn't it? So let's try negative 5. So y of 0. So I'm just going to write these off here to the side. We're going to get x equals negative 5. Trace, that looks like negative 2. We get a y of 0. And that looks like positive 2. Y of 0. So really and truly, that's all you need to do to be able to get these. Graph it. Where is it crossing the x-axis? If you wanted to do this by hand, to factor by grouping, notice I have 1, 2, 3, 4 terms. We have 4 terms. That's when you want to factor by grouping. So we'll group the first 2 here together. What is my GCF of this first 2? This has 3 x's. This has 2 x's. I can take at least 2 x's out. And that will leave me with x plus 5, right? If you distribute that back, x squared times x is x cubed. X squared times 5 is 5x squared. Then look at your GCF in that second grouping. Both 4 and 20 are divisible by 4. And when we factor, we always want this first number positive. So I'm going to factor out a negative 4. So negative 4x divided by negative 4 is x. Negative 20 divided by negative 4 is positive 5. So notice I have the same thing here in parentheses. So that comes out once. And then my GCFs here make up my second binomial. X squared minus 4. Now this is not fully factored because I have an x squared here, so I can factor this out more. This one here is called a difference of squares. So x times x gets me to that x squared. What do you multiply together to get 4? and that's 2 times 2. And to make that a minus 4, you need one positive and one negative. So if I said x plus 5 equal to 0, we would subtract that over, and we would get x equals negative 5, which we found from that graph. If I set that equal to 0, we'll subtract that 2 over and get x equals negative 2, which we also got from that graph. And if I set x minus 2 equal to 0, add the 2 over, and we get x equals 2, which we also found. So this way is much quicker. This way is not hard, but it does take some time. Now I do want to show you something in case you go straight into the graph and how these are all whole numbers. They're easy to tell, they're easy to verify. But if I put one like this in and I get fractions right here, I want to show you how to get to these fractions. So I'm going to put this one back in one more time. And here is my graph. And because these are so close together, I'm actually going to zoom in a little bit more. So let me change my window. -6 to 2. And this really doesn't matter, so let's just go -5 to 5. So I'm just going to zoom in some. Okay, so with this one, I can just count over. That's 1, 2, 3, 4, 5. So I would do trace -5. But I can see here that these two are in between whole numbers, and we know what fraction they are. But in case we didn't, there's infinite amount of fractions in between there, right? That could be 1/2, that could be 1/4, that could be 2/5, that could be 2/7. I have no idea what it is if I, didn't solve it. So what we'd have to do is go to our calc again. Go second trace to go to calc. And if I am wanting to find x-intercepts, that's the same as a 0. So let's say I wanted to find this x-intercept first. I need to go somewhere to the left of it, but I want to get a little bit closer than I am. Let's keep going till we see our cursor. Okay, there's my cursor. So if this is my x-intercept, I am to the left of that x-intercept. So I'm going to hit enter. Now I need to go to the right. So I want to go somewhere down over here. I don't want to go too far to the right where I am past another x-intercept. So I need to go somewhere over here. I could be down here and that's fine. I haven't gone past this one, but I am going to go more up here. Okay, hit yes through graph and you get that -0.3 repeating, which is -1/3. So one more time to show you again, if I wanted to get this one here, we'd go second trace to go to calc. I'm finding an x-intercept, which is the same as a 0. I need left and right bound. So if this is the x-intercept, I need somewhere to the right, but not so far, or sorry, somewhere to the left, but not so far to the left that I go past another x-intercept. So this would actually be fine right here, but I am going to go a little bit closer. Go right there. Now I need to the right. That is to the right of this x-intercept here. Hit enter through the guess, and we get that 0.5. So if it's not a whole number and you can't sit there and trace and guess that fraction, you need to go to second calc and go to 0.